Welcome to Raaonline. Today we are going to talk about the extraocular muscles, and as you know that extraocular muscles can come as a clinical based question for you. Either the patient has a medial squint or a lateral squint or a strabismus, or it can also come as a direct question in which you have to enumerate the extraocular muscles, you would have to talk about their origin, their insertion, and also you have to talk about the actions of the extraocular muscles. So, enumerating the extraocular muscles, we have 7 voluntary muscles and 3 involuntary muscles. So, what are the 7 voluntary muscles we are having in the extraocular muscles? We have the superior rectus, the inferior rectus, the medial rectus and the lateral rectus. So, the 4 recti which are all taking origin from a common place, that is at the apex of the orbit, and which is from the annular ring of the Zinn, or it is a fibrous ring which is attached to the apex of the orbit. Next is we have the superior oblique and the inferior oblique muscles which has peculiar origins. Basically, the superior oblique is taking origin from the body of the sphenoid and taking a course which is very unique. It crosses the entire roof of the orbit and then winds around the pulley which is attached to the anterior medial aspect of the roof of the orbit and goes back and inserts to the eyeball in the posterior superior quadrant. Inferior oblique also has a unique origin which I will be talking to you. It is taking origin from the floor of the orbit, anterior medial part, and then goes below. It is actually sandwiched between the inferior rectus and the floor and then deep to the lateral rectus and inserts very close to the superior oblique. That is at the posterior superior quadrant of the eyeball. Another voluntary muscle which is though not directly working for moving the eyeball or causing any movement of the eyeball but has to be considered over here is because of its typical origin, which is very close to the superior oblique, and that is the levator palpebrae superioris, and mainly it raises the upper eyelid. Now coming to the involuntary muscles, we have the superior tarsal muscle which is the Muller's muscle, the inferior tarsal muscle and the orbitalis muscle. So these are the 3 muscles which are involuntary muscle and they are actually they are having parasympathetic and sympathetic like nerve supply also, especially from the parasympathetic nerve supply. So superior tarsal elevates the upper eyelid and inferior tarsal depresses lower eyelid. So it does not elevate, it acts on the lower eyelid and it depresses the lower eyelid. So now coming to the to make you understand that if this is the 2 orbits, if you can see, I told you even in the orbit class that the medial walls of the orbit are parallel to each other and both the lateral walls are sloping backwards and they join each other at an angle of 90 degrees, whereas the medial wall and lateral wall will form an angle of 45 degrees to each other. And there is a common tendinous ring of Zinn which is attached to the middle part of the superior orbital fissure and it also encloses the optic canal. So let's see where this common tendinous ring of Zinn is. Exactly at the apex of the orbit it is coming. So this common tendinous ring of Zinn is actually getting attached, so it is taking a part of the whole optic canal. Along with that, it is also dividing the superior orbital fissure into 3 parts. That is the superior part, the middle and the inferior part. So that is the common tendinous ring of Zinn, and you can see over here. So if this is the eyeball, so from the common tendinous ring of Zinn, medial aspect, you can see this medial rectus is taking origin and comes lateral part, you have the lateral rectus, superior part, you have the superior rectus, and inferior part, you have the inferior rectus taking origin. So this is how the ring of Zinn is giving origin to one muscle from each part. Now coming to the insertion of these muscles. Now these muscles are all inserted into the sclera. Now, if we have to divide the eye, so if this is the eye, if you see this is the eye and this is the anterior part of the eye, so you are getting the cornea over here, and if you are having if you put a line like this, which is cutting across the eyeball from the one pole of the eyeball to the other pole of the eyeball, a vertical plane, then in this part, so this is the posterior part of the eyeball, whereas this is the anterior part of the eyeball, and this is called the equator of the eyeball. So in the vertical axis, so this is the equator of the eyeball. So this is the eye over here. You have the pupil and you have the eyeball. So if you are dividing the eyeball into an anterior and a posterior half, then this is called the equator of the eyeball, and whatever happens in front, this becomes the anterior segment and this is the posterior half of the eyeball. So now this superior rectus, inferior rectus, medial rectus, all these are inserting, all the recti are inserting into the anterior half. Okay, so in front of the equator. So this is called the equator of the eyeball. Okay, they are all inserting in front of the equator of the eyeball, and it is some distance from the sclerocorneal. This is the sclerocorneal junction. So at different distances from the sclerocorneal junction. Okay, or limbus. So this is called the limbus. So there are some terms which you have to get used to understand the insertion of the recti. So they are inserted into the sclera, little posterior to the limbus, and this is giving the average distance of the insertion posterior to the limbus. So limbus is nothing but the sclerocorneal junction.